Hi everyone. Today we will discuss a new plot in the statistical field, and we want to explain the meaning and what this plots represent. So today the section is entitled box plots. What we mean by box plots and what are the main elements to plot a box plot. So first of all, what a box plot means. Normally, we should know first of all that a box plot uses only five specially selected numbers to display information about numerical scores in a graphical form. What are these five numbers? The five numbers are the lowest score from the list of scores, okay? Then the lower quartile, median, upper quartile, and highest score. So it is easy to know and to find the lowest score, the highest score, the median, and we explained in previous session how to find the lower quartile, upper quartile of given or a series of numerical score. So the highest, first of all, we should know that the extremes are the lowest and the highest score. Okay, the middle score is represented by the median, and the upper and lower quartiles are the quarter of these numerical values. So these five numbers make up the five-number summary. Okay, what I can hint on you is about, you should know that in general, the bottom 25% of the scores take values from the lowest to the lower quarter. So normally this distance or this length or this portion of this plot represent the bottom 25% of the scores. Secondly, this 25% here, we have it resides 25% of the scores also, but the second part of the scores. Okay, normally in this box, limited by the lower quartile and the upper quartile, contains 50%, the middle 50% of the scores lie between the lower and the upper quartile. Okay, so it is easy. As we said, it is easy to find and to plot and to explain what each box plot represents. So here in the if we move on to the exercise 2, they gave us some box plots, and they ask us to find, for example, the highest, lowest score, the range of score, the median, upper quartile, lower quartile, and interquartile. So it is easy. For example, we have here in C, we have this one. We know that the extremes, okay, are the lower, the lowest score here, the highest score. So first of all, we should know the step size here. So we have it 1, 2, 3, and 4, and 5 as a 10. So with the scale here, each size step size is equal to 2. Okay, so normally 12, 14, 16. So normally 16 is the lowest score, and here 42, 44, 46 is the highest score. Easy. Okay, and the lower quarter, the upper quarter. So the lower quarter is here. So normally 22, 24, 26. So it is 26. And the upper is about 40 to 1. It is like 32, 34, 36, 38, and 39. So what is it? 39. So from the highest and the lowest score, we can conclude the range of the scores by subtracting the lowest from the highest score to obtain 30. And the upper quarter, lower quarter, we obtain the interquarter range. So it is like 39. We subtract lower quarter from the upper. So we obtain 13. You should know that the interquarter is more contains more information than the range of the scores, especially when outliers exist. Okay, the median is 29. So why? Because this slide or this part, okay, represents the median. Okay, this thing. So it is like 29 because we have a 28 and the half, so 29. So it is easy to find how to read each one of these box plot. How can we plot a box plot? So it is easy. We need these 5 numbers, these special elements, 5 special elements, like the lowest, highest scores, a lower, upper quarter, and the median. We find here that the median is far away from the lower quarter. And it is nearest from the upper. Okay, why? We should know that 25% of the scores are scattered here, scattered closely to the median, and here they are widely scattered far from the median, the 25% of the scores. Okay, so we determine the values of the quarters and extremes through the box plot, because we have the highest 65, the lowest 42, so we can use an adequate step size. For example, we can use 41, 42, 43, 45, 4, and 45. It is easier to take a step size for each step size equal to 1, okay, on the horizontal axis. So it is easier. But if we have big values, great values, we should, and it is more adequate to take step size, for example, for one step size, for example, equal to 5 or 2 or 3 or whatever. Okay, so we put the lowest, the highest, the upper, the lower, and the upper quarter, and the median. Here the median 55, 6, 7. So it is a 58. Okay, 56, 7, 8. So 58 is the median. So we will obtain, we use the 3 quarters to form the box. Normally only the 3 quarters. Quarter 1, the lower quarter. Quarter 2, Q2 is the median, and the Q3 is the higher quarter to form and to shape our box. Good. Normally in the next exercise, we have a list of numbers, and we want to find and to draw our box plot. So here, first of all, we should put the numbers in ascending order: 18, 20, 22, 23, 25, 29, 30, 30, 30, 31. Good. So check. Secondly, we want to find the median. So we want to find the median. We can use the manual way. We cross out a value from the right and from the left at the same time, simultaneously at the same time, to finally obtain the middle value or the 2 middles value So normally one from here, 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 and one from here. Two middle values remain. So normally they are the two middle values. To obtain the median, we count or we calculate, evaluate their average. So 25 plus 29 over 2 will obtain 27. So normally the median is here in the middle, between 25 and 29, 27. Good. In this way, we have the half of the numbers we have it to the left of the median, and to the right of the median we have the second half of these numbers. So we have 1, 2, 3, 4, and 5. We have a 5 here. So we start to cross out to obtain the first quarter, Q1, or the lower quarter. So we cross 18 and with the 25, 20 with 23 to obtain the middle value is 22. So the lower is 22. Lower quarter. Similarly, we do the same, 29 with 31, 30 with 30. We will obtain the middle value 30, so it is the third quarter, or what we call the upper quarter. So 30 is the upper quarter. So in this way, we use the 3 quarters, the lower, the upper, and the median to plot our box, and we use the extremes as the lowest and the highest score to obtain the whole image and the entire image that we want to obtain. So finally, in this section, I'm going to explain how to compare two box plots. So here we have a 2 set. Indeed, we are talking about the same subject for 2 sets, for 2 classes, for 2 anything. So normally we have a set A and set B. We have 2 different box plots, and we want to describe the similarities and the differences between the two and their what they represent. Okay, and we want to interpret the results. So first of all, 2 data sets are shown in these parallel box plots. Okay. They ask us to describe any similarities in the data set. So normally we can remark clearly that we have this cut, this thing here, the same. And we know that this cut is a part of the box plot. So it is the median, the second quarter, the median. So normally we have the same median, 40. We have the same median. So as similarities, we have, first of all, the greatest score and the median are the same for both data sets. So normally we have the median the same, and we have the highest extreme boundary, which we call the highest score, the same 70. So the greatest score of both is 70, and for both the median is 40. Okay, in this way, we already described the similarities between the data sets. So they ask us to compare the range of set A with that of set B, the range of, okay, good. First of all, we can go to compare them using the, for example, the spread of score about the median. How to compare the spread of, for example, of scores about the median? We can use range of, okay, the range, okay. The range, they ask the range, so it is easy. Highest minus lowest, and here highest minus lowest. So normally the range here, the range, for example, 70 minus 20 is 50 for set A. For set A is 50. Okay. For set B, we have a 70 minus 10 is 60. So there is the set of the range of set B is greater than set A. So it means that the scores are widely spread in the set B more than in set A. No good, no problem. For which data set the middle 50% clusters more closely to the median. What they mean by the middle 50%? The middle 50% is represented by the box. here the box. So this box contains the middle 50%, and this small box contains the 50%. Normally, if the box is smaller, when the box is smaller, so normally the middle 50% is clustered more closely to the median. Normally, which one is tiny, is smaller than the other. So normally the green one, the set B, is smaller. So normally we can say that the middle 50% in the set B is more closely clustered to the median than in set A. In which data set, and we can say, or also we can use the interquartile of set A. So to find which one is we can remark by using our eyes, okay, clearly vision. It is very visible here that set B, the box is smaller, but we can also compute it numerically by computing the interquartile of set A and the interquartile of set B. So normally the higher quarter minus the lower quarter, higher quarter, lower quarter, and each one corresponding to each set to obtain 30-20. So in set B, we can say that spread of scores above the median is less for set B than set A, less than. So in set B are more closely clustered to the median. Okay, good. Moving on to the last one, in which data set the top 50% of scores more closely clustered to the median. The top 50% of scores more closely clustered to the median. So normally the top 50% of scores are spread over the same interval. The scores between Q2 and Q3 will show any clustering. Q3 is closer to the median for set B. We know that Q3 here. So here it's more closely to the median, and here more closely to the median. So the 25% here, 25% are more closely to the median, because we can't compare or base our comparison to for example this one, the highest score, because in both sets the highest score is the same. So normally we calculate that Q3 is closer to the median for set B than for set A, that 25% of scores between Q2 and Q3, and hence the top 50% for set B are closer to their median. As I said before, we base our comparison to the 25% located here between Q2 and the Q3, between the median and the Q3, because both sets have the same highest score. And it is easy also to complete these exercises by yourself. It is very easy to find a way to compare rightfully the different box plots, given box plots. These are the important information, and with this section we accomplished our chapter, and see you soon in the next chapter. Bye bye.